Welcome to Anselm Griffin's occasional series of YouTube tutorials for Matlab. Today we're back to, well, one of my favourite areas anyway, and that's image processing, I suppose, slash bit of homography, and we're looking at measuring planar objects with a calibrated camera. Now, just to be clear about this, the code is completely Matlab's. If you need the code, there it is yourself. But I just decided I'd run it and comment on it, and hopefully between the two of us, if you were into this sort of thing, that you'd be able to get a better appreciation. So I ran the code and I put in one or two extra comments myself, and I have it as a PDF. So what are we trying to do? We have a checkerboard image there. We've put a couple of pennies, or US pennies, and if we go down towards the end, we're able to get the diameter in real world coordinates of the first penny. You can obviously do it for any number of pennies you want. 19.18 there. The second one, 18.88. It's 19.05 is the true answer. And we can also get the distance from the penny to the camera, or the camera to the penny, and we just, there it's 759.69 millimeters. So let's go up to the top and let's just run through it. So there's the first bit of code. These are pre-supplied with Matlab. So we just set up the little for loop and we read in the 9 images. We set the magnification to 25%, and we're just going to show one at 25% there. So there we are. Now obviously when you take that picture with the camera, there's a number of things wrong. There would be a bit of lens distortion with the camera. Now if you're using a high grade SLR, the distortion would be much less than, say, a cheap camera or a wide lens camera, something like an 8, 10, 12 millimeter camera. So those 8, 10, 12s would have quite big barrel distortion at the edges. So what we want to do here is, we've got, first of all, we want to estimate the camera parameters, the intrinsic and the extrinsic. We detect the checkerboard points. We let that know the square size, that's the paper, and we've done that as 29 millimeters square. And we generate what would be the checkerboard in what it should be, using 29. Okay, so we now want to get the intrinsic, that's the focal length, principal point offset and axis offset, and we also want to get the rotation and the translation from the extrinsic parameters. I assume you know all of this. There's the Matlab command to do that. And then we compare what they actually are with the reprojection. So just there, we're getting the reprojection error. So we're comparing what we estimate them to be and what they actually are. Remember, there's 9 images, so we're getting an overall mean error just there for each individual image. So it's bopping in, if you take the overall average, to be about 0.83, 0.84 of a millimeter. Okay, there, 0.84. So now we're going to load the image to be measured. So we're going to just read it in there. So we're looking at image 9. There's the input image. So we want to get the diameter of that lad, and then the distance of that penny from the camera. And we could, if we wanted, to get the distance of that penny from the camera. We have to undistort the image because remember there would be the focal length and the axis skew and all of that stuff. So we run, there's the command undistort image. There's the undistorted image. We're now ready to do some measurements. To do that, we have to segment out the coins. Now, we could just do it in RGB mode, but I think Edens, or Steve Edens, who would be sort of the guru of image processing, prefers to go the hue saturation value route. So we convert it from RGB to hue saturation value. And again, I hope you know what the saturation is. I have some extra comments there, but you can look it up yourself. Just there. The saturation describes the intensity or purity of the hue. We threshold it out and we show it. So there it is. So there's the 2 pennies. Now we detect the coins. Now there is, just go back there, white. They are white. There's also other bits of white. So you want to be some way of just picking up the big pennies. So this is the only bit I have a problem with. Just there, Matlab puts in 200. Now it doesn't say why it's 200. So what we're saying is we want to get the minimum blob area is 200 pixels that are connected to each other. Now Matlab doesn't explain where the 200 came from. They just made an intelligent guess. So we get all of that. We pick the 2 largest components, and then we just record just there. We just record in the system shift caused by the undistorted image. We display it and then we label it down here. So there we are, we have them labeled. Now we need to dig out the rotation and the translation to get the world coordinates. We have them there. We measure the first coin using the box parameters. We convert them to world coordinates and then we display the diameter of the first one, that's 19.18. Measure the second coin in the same way. We get 18.88, and then finally we get the distance from the first penny to the camera, and the code is given there. I'm not going to go through it because this is not it'd be too long to do it step by step. Just hope you know what's going on. And we get 759.69 millimeters. Okay, so hope that helps a little, and thanks very much for listening.